our journey. We spent a few days in our magnificent spaceship, but now we have to land on Titan. So, what is our problem? Titan is really close to Saturn, so we're going to be attracted by Saturn, and we just want to be attracted by Titan. Then we need to find the best position where we'll be attracted by Titan, and its attraction will be larger than the attraction from Saturn. So let's assume this is somewhere between the middle of this distance and Titan. So let's say it's there. So we can write that the distance between Titan and the spaceship will be x. This is what we're looking for. So this distance will be the largest distance we have, d minus x. So if we want to find x, we need to find an equation where we can get x. We assume that the gravitational force from Titan has to be larger than Saturn's ones, so it means that we have this equation. This is the gravitational force from Titan, which has to be larger than the one of Saturn on the spaceship. So now let's get the expression for this. So we have the expression for each force, and we can see that we have on both sides we have g, the gravitational constant, so we can raise g. We have m and m, which is the mass of the spaceship. So we get now this equation, which is more simple than the first one. Now in this equation we have to make appear x, because we're looking for x. X is a distance, so we have to change both these distances and express them with x. So what we get is that. So why can we get these things? It's just because the distance between Saturn and the spaceship is made of the radius of Saturn plus the distance between the surface of Saturn and the spaceship, which is d minus x. In Titan's situation, we have the radius of Titan plus x. So that's why you have these expressions. So now what we're doing is to get x. So as x was under the line, we have to put it on the line on the top of the quotient. So we just multiply these parts of the equation by this one in order to get rt plus x squared on this side. So we do the same now on this line with this part. If we want to put it there, you have to multiply by empty. So we get this. Now, as we want to get x, we need to skip this squared power of 2. So what we can do is just to take the square root of all the equation and just have one problem. Now I have it. So we have the square root of all the expression, and what happens is that we just have the square root of each mass, Saturn and Titan, and the square disappears because rt plus x squared, if we take its square root, we just get rt plus x. And we have the same situation for rs plus d minus x. Now we just develop, meaning that we forget this, so this is a mistake. Don't have this parenthesis. And what we can see is that we have some terms, this one and this one with x. So we're gonna put them on the same side of the equation. As we have a minus just there, we put it on the left, it becomes plus. This one that does not concern x has to be put on the right. So as this is a plus, it becomes minus. So we get now this, and we have two parts with x and all these things which are constants with masses, radius and the distance. So what we can do, just see that x is the common factor of both terms, so we get this, and as we want to isolate x, we just need to put this part on the right. As it multiplies x, we just divide it on this side. Then we get this equation. Now let's solve this equation. To do that, you need the data, which are just there, and what you're gonna find is x has to be shorter than 1.69 times 10 to the power minus 7 meter, meaning that the spaceship has to be really close to Titan to be sure that the attraction of Titan will be larger than the attraction of Saturn.